नमस्ते दोस्तों, स्मार्ट माइंड्स ट्यूटोरियल्स में आपका स्वागत है। आइए आज कुछ नया सीखें।
So let us get started with Laplace transforms. So first let me give you the definition for Laplace transforms. Let f of x be a function defined for every positive x. Then the Laplace transform of f of x denoted by L of f of x is defined by L of f of x is equal to integral 0 to infinity e power minus sx f of x dx, provided that the integral exists. S is a parameter which may be real or complex. Okay, now L of f of x can also be written as f bar of s, which can also be written as f of x is equal to L inverse of f bar of s. These are the three different ways where you can write it. So here f of x is called inverse Laplace transform. Inverse Laplace transform of f bar of s, and the symbol L which transforms f of x into f bar of x, that is called Laplace transform operator. Okay, now let us do a few problems. Find the Laplace transform of number 1, f of x is equal to 1. Number 2, f of x is equal to x. Number 3, f of x is equal to e power ax. Number 4, f of x is equal to sin ax. Number 5, f of x is equal to sin h ax. Let us find Laplace transforms of all these functions. So let us take the first bit. What is L of f of x? That is L of 1, which is equal to integral 0 to infinity e power minus sx into 1 dx. Now what is integral e power minus sx? It is e power minus sx by minus s. Why? Because integral e power ax is e power ax by a. From limits 0 to infinity, that is equal to 1 by s. So minus 1 by s is a constant into e power infinity minus e power 0. So that is minus 1 by s into 0 minus 1, which is equal to 1 by s, where s is greater than 0. Now let us take the second bit. What is the second bit? F of x is equal to x. So what is L of f of x? That is L of x. Now we apply the formula integral 0 to infinity e power minus x into x dx. So that is equal to, now we need to apply UV rule here. So which is equal to, if you find UV rule here, we take u e power minus sx as u and this as v. So what is UV rule of integration? Integral UV dx is equal to u integral v dx minus whole integral dy dx of u integral of v dx whole dx. This is UV rule of integration, which is also called as integration by parts. So if you apply this formula, you will get minus x e power minus sx by s minus e power minus sx by s square, if you apply this formula into from 0 to infinity. Now if you apply first infinity then minus 0, upper limit minus lower limit you have to apply. So if you apply this, you will get 1 by s square. Take the next bit. What is the third bit? F of x is equal to e power ax. So find L of f of x here. In the place of f of x, we can take e power ax. Now we'll apply the formula integral 0 to infinity e power minus sx into e power ax dx. Now here bases are same, we can add the powers. 0 to infinity e power minus of s minus a into x dx. That is, if you integrate this, what will you get? Minus e power minus of s minus a into x by s minus a. After normal integration, you divide with the coefficient of x from 0 to infinity. So if you apply upper limit minus lower limit, you will get 1 by s minus a. In every step you write where s is greater than a, because denominator should not become negative or 0. Take the next bit, fourth bit. What is the fourth bit? F of x is equal to sine ax. So first we need to find L of f of x. That is equal to L of sine ax, which is equal to integral 0 to infinity e power minus sx into sine ax dx. Now we have a formula for this. What is the formula? E power minus sx by s square plus a square into minus s sine ax minus a cos ax. Here also we can apply UV rule to find this. So that is equal to, if you apply the limits, you will get a by s square plus a square. Now let us take the last bit, fifth bit. What is fifth bit? F of x is equal to sine h ax. So what is L of f of x? In the place of f of x, we will write sine h ax. That is equal to integral 0 to infinity e power minus sx sine h ax dx. That is equal to integral 0 to infinity e power minus sx. What is sine hax? We have a definition for sine hax. You can write it as e power ax minus e power minus ax by 2. This is the formula for sine hax. Okay, for sine you take minus here, for cos you take plus. So that is equal to 1 by 2 outside integral 0 to infinity. Now here we can multiply this into this into this. So you will get e power minus of s minus a into x dx minus integral 0 to infinity e power minus of s plus a into x dx. That is 1 by 2 into this is nothing but L of e power ax minus this is nothing but L of e power minus ax. Now we have a formula for L of e power ax. This is 1 by s minus a minus what is formula for L of e power minus ax? 1 by s plus a. So that is if you take LCM you will get a by s square minus a square where s is greater than mod a. Now let me give you some properties of Laplace transforms. These are very important. So the first property is if A, B, C are constants and F, G, H are functions of x, then L of AF of x plus BG of x minus CH of x is equal to A into L of f of x plus b into L of g of x minus c into L of h of x. That is, L is a linear operator. This is the first property. Now what is the second property? This is called as first shifting property. Very, very important. First shifting property. So if L of f of x is equal to f bar of s, then L of e power ax f of x is equal to f bar of s minus a. These are the two main properties. Now let us solve some questions. Now using the first shifting property, we have a few important results. So note down those results. L of e power ax x power n is equal to n factorial by s minus a power n plus 1. L of e power ax sin bx is equal to b by s minus a whole square plus b square. L of e power ax cos bx is equal to s minus a by s minus a whole square plus b square. L of e power ax sin h bx is equal to b by s minus a whole square minus b square. Now L of e power ax cos h bx is equal to s minus a by s minus a whole square minus b square. These are a few important results we got from first shifting property. Take the next question, very, very important. Find the Laplace transform of sine 2x, sine 3x. Now, we have a formula for sine A, sine B. That is sine 2x, sine 3x can be written as 1 by 2 into cos x minus cos 5x. How did I get this x? I subtracted 3x minus 2x. Then how did I get this 5x? I added 2x plus 3x. Okay. So we have a formula. Sin A sin B is equal to 1 by 2 into cos A plus B. Sorry. Cos A minus B minus cos A plus B. This is the formula. This formula I applied in the first step. Now, to find out L of sin 2x sin 3x, that is 1 by 2 outside, L of cos x minus L of cos 5x. Now we have a formula. L of cos x is s by s square plus a square, or L of cos ax. L of cos ax is s by s square plus a square. Now when you are finding L of cos x, put a is equal to 1. So s by s square plus 1. Here we put a as 5 minus s by s square plus 25. Okay. So if you take the LCM here, what do you get? S by 2 into cross multiply s square plus 25 minus s square minus 1 by s square plus 1 into s square plus 25. S square minus s square cancel. That is s by 2 into 24 by s square plus 1 into s square plus 25. We can cancel 2 ones are 2 12s are. So that is 12s by s square plus 1 into s square plus 25. This is the final answer. Now I will give you a list of formulae in Laplace transforms. So first formula is L of 1 is 1 by s, where s is greater than 0. L of x power n is n factorial by s power n plus 1, where n is 0, 1, 2 and so on. Number 3 is L of e power ax is 1 by s minus a, where s is greater than a. L of sin ax is a by s square plus a square, where s is greater than 0. L of cos ax is s by s square plus a square, where s is greater than 0. L of sin hax is a by s square minus a square, where s is greater than mod a. L of cos hax is s by s square minus a square, where s is greater than mod a. Then L of x power n e power ax is n factorial by s minus a power n plus 1. L of e power ax sin bx is equal to b by s minus a whole square plus b square. L of e power ax cos bx is s minus a by s minus a whole square plus b square. L of e power ax sin h bx is b by s minus a whole square minus b square. L of e power ax cos h bx is s minus a by s minus a whole square minus b square. L of x power n minus 1 by n minus 1 factorial is 1 by s power n, where n takes values from 1, 2, 3, 4 and so on. Then L of e power ax x power n minus 1 by n minus 1 factorial, which is equal to 1 by s minus a whole power n, where s is greater than a. Now L of e power ax minus e power bx by a minus b is 1 by s minus a into s minus b, where a is not equal to b. L of a e power ax minus b e power bx by a minus b is s by s minus a into s minus b, where a is not equal to b. Now L of 1 by 2a cube into sin ax minus ax cos ax is 1 by s square plus a square whole square. L of cos ax minus cos bx by b square minus a square is s by s square plus a square into s square plus b square, where a square is not equal to b square. L of a sin bx minus b sin ax by ab into a square minus b square, which is equal to 1 by s square plus a square into s square plus b square, where a square is not equal to b square. Now L of x by 2a sin ax is equal to s by s square plus a square whole square. L of x cos ax is equal to s square minus a square by s square plus a square whole square. L of x power k minus 1 is equal to, the symbol is gamma, gamma of k by s power k, where k is greater than 0. Now L of x power minus 1 by 2 is gamma of 1 by 2 by s power 1 by 2. Always remember, gamma of 1 by 2 is root pi. Root pi by s power 1 by 2. Then L of 1 by root pi x is 1 by s power 1 by 2. L of 2 by root x by pi is 1 by s power 3 by 2. Now let us find the inverse transforms of these 4 bits. So these are the 4 functions whose inverse transforms we need to find out. First, let us take the first bit. We need to find out L inverse of s square minus 3s plus 4 by s cube. Now you can separate this. That is L inverse of s square by s cube minus 3s by s cube plus 4 by s cube. that is L inverse of 1 by S minus 3 by S square plus 4 by S cube. Now let us separate it. L inverse of 1 by S minus 3 is a constant. We will bring it out. L inverse of 1 by S square plus 4 is a constant. L inverse of 1 by S cube. Now L inverse of 1 by S is 1 minus 3 into L inverse of 1 by S square is X plus 4 into L inverse of 1 by S cube is X square by 2 factorial. 2 factorial is nothing but 2. So 2 ones are 2 twos are. That is 1 minus 3x plus 2x square. This is the final answer for the first bit. Now let us take the second bit. We need to find inverse Laplace transform of s plus 2 by s square minus 4s plus 13. So that is L inverse of s plus 2 by. Now see denominator, how can we write? We can write this as s square minus 4s plus 4 plus 9 we can write. We can write 13 as 4 plus 9. Now if you see the first three terms in the denominator, s square minus 4s plus 4 is s minus 2 whole square plus 9. 9 can be written as 3 square. That is L inverse of now s plus 2, how can we write? Can we write plus 2 as minus 2 plus 4? Now we can separate it. S minus 2 by s minus 2 whole square plus 3 square plus 4 into L inverse of 1 by s minus 2 whole square plus 3 square. Now this is the formula for e power 2x cos 3x, and formula for L inverse of this is 1 by 3. So this will become 4 by 3 e power 2x sine 3x. This is the final answer for the second bit. Let us take the third bit. So in the third bit, first let us split it into partial fractions. So what is the given question? 2s square minus 6s plus 5 by s cube minus 6s square plus 11s minus 6. So denominator, if you split it into factors, we will get 2s square minus 6s plus 5 by s minus 1 into s minus 2 into s minus 3. Now this you can split it as a by s minus 1 plus b by s minus 2 plus c by s minus 3. On the left hand side we can write 2s square minus 6s plus 5 by s minus 1 into s minus 2 into s minus 3. Now if you find ABC values using partial fractions method, we will take the LCM first and we will cancel the denominators. So 2s square minus 6s plus 5 is equal to a into s minus 2 into s minus 3 plus b into s minus 1 into s minus 3 plus c into s minus 1 into s minus 2. Now put s is equal to 1. If you put s is equal to 1, second and third term will become 0. And here you will get 2 into 1 minus 6 into 1 plus 5 is equal to a into 1 minus 2 is minus 1, 1 minus 3 is minus 2. So this is 2 plus 5 is 7, 7 minus 6 is 1. 1 is equal to 2a, that means a is equal to 1 by 2. Now the same way, if you put s is equal to 2, first and last term will become 0. So 2 into 2 square minus 6 into 2 plus 5 is equal to b into 2 minus 1 is 1, 2 minus 3 is minus 1. Here this will become 2 square is 4, 4 to the 8, 8 plus 5 is 13, 13 minus 12 is 1. 1 is equal to minus b, that means b is equal to minus 1. You got a value and b value. The same way we need to find c by substituting s is equal to 3. So you will get, if I put s is equal to 3, first and second term will become 0. So you'll get 2 into 3 square minus 6 into 2 plus 5 is equal to c into 3 minus 1 is 2 and 3 minus 2 is 1. So 9 to the 18, 18 plus 5 is 23, 23 minus 12 is, let us substitute this. So 2 into 3 square minus 6 into 3 here. So this is 9 to the 18 and this 18 and 18 get cancelled. You will get c is equal to 5 by 2. So you got ABC values. After getting ABC values, let us find L inverse of 2s square minus 6s plus 5 by s cube minus 6s square plus 11s minus 6, which is equal to half of L inverse of 1 by s minus 1 minus L inverse of 1 by s minus 2. Now here I substituted ABC values and in the same step I am separating it 1 by s minus 3. So this is 1 by 2. What is L inverse of 1 by s minus 1? It is e power x minus e power 2x plus 5 by 2 e power 3x. This is the final answer. Now let us move on to fourth bit. Here what is the question given? Question is 5s plus 3 by s minus 1 into s square plus 2s plus 5. Now here if it put s is equal to 1, what do you get? 5 into 1 plus 3 by s minus 1 into 1 square plus 2 into 1 plus 5 plus as plus b by s square plus 2s plus 5. Here we are separating this into partial fractions. Now if you solve the same like the last problem, you will get a is equal to minus 1 and b is equal to 2. So L inverse of 5s plus 3 by s minus 1 into s square plus 2s plus 5 is equal to, now we will separate it, L inverse of 1 by s minus 1 plus L inverse of minus s plus 2 by s square plus 2s plus 5. That is L inverse of 1 by s minus 1 plus L inverse of, this we can write minus of s plus 1 plus 3 by s plus 1 whole square plus 4. Now again we have formulas for this. So now this can be separated again as L inverse of 1 by s minus 1 plus L inverse of s plus 1 by s plus 1 whole square plus 4 can be written as 2 square plus 3 L inverse of 1 by s plus 1 whole square plus 2 square. That is L inverse of 1 by s minus 1 is e power x minus e power minus x cos 2x plus 3 by 2 e power minus x sin 2x. This is the final answer. Now let us understand transforms of derivatives. So there are three theorems over here. We will understand the statements of these theorems. If f dash of x is a continuous function and L of f of x is equal to f bar of s, then L of f dash of x is equal to s f bar of s minus f of 0. Next is theorem 2. Second theorem is if f of x and its first n minus 1 derivatives are continuous, then L of f power n of x is equal to s power n f bar of s minus s power n minus 1 f of 0 minus s power n minus 2 f dash of 0 minus so on up to minus f power n minus 1 of 0. Next is third theorem. If L of f of x is equal to f bar of s, then L of x power n f of x is equal to minus 1 power n d power n by ds power n into f bar of s, where n takes values 1, 2, 3, so on. These are the transforms of derivatives. The same way we have transforms of integrals. So let us take the first theorem. If L of f of x is equal to f bar of s, then L of integral 0 to x f of u du is equal to 1 by s f bar of s. Or we can write it in another way. L inverse of 1 by s f bar of s is equal to integral 0 to x f of u du. This is the first theorem. And the second theorem is if L of f of x is equal to f bar of s, then L of 1 by x f of x is equal to integral s to infinity f bar of s ds. Now using the transforms of derivatives and integrals, let us solve a few problems. Find the Laplace transforms of x cos ax, and the second bit is x cube e power minus 3x. So first let us take the first bit. Since L of cos ax, we have a formula for this. What is the formula? S by s square plus a square. So we have L of x cos ax is equal to minus d by ds of s by s square plus a square. Now how to differentiate this with respect to x? You need to apply u by v rule. What is u by v rule? In the denominator we get v square, that is s square plus a square whole square. Let me give you the u by v rule here. D by dx of u by v is In the denominator, you get v square, v derivative of u minus u derivative of v. So first we write the denominator as it is, and then we differentiate the numerator. Derivative of s is 1. Minus, now we write the numerator as it is, and we differentiate the denominator, that is 2s. And outside you have a minus, write that minus as it is. So that is minus of s square plus a square minus 2s square by s square plus a square whole square. So that is minus of a square minus s square by s square plus a square whole square. If you take this minus inside, you will get s square minus a square by s square plus a square whole square. Now the second bit is, again, since L of e power minus 3x, what is the formula? 1 by s plus 3. So what do we have? We have L of x cube e power minus 3x is minus 1 whole cube d cube by ds cube 1 by s plus 3. Now if we differentiate this function 3 times, what do you get? 6 by s plus 3 whole power 4. This is the final answer. Take the next question. Find the inverse transform of 1 by s into s square plus a square. Now, since we know that L inverse of 1 by s square plus a square is 1 by a sine ax, we have this formula. Therefore, from the first theorem of integration, we have L inverse of 1 by s into s square plus a square is integral 0 to x 1 by a sine ax dx. That is 1 by a square into minus cos ax from 0 to x. So if you apply upper limit minus lower limit, you will get 1 minus cos ax by a square. This is the final answer. Take the next question. Find the Laplace transforms of 1 minus e power x by x. Now since we know that L of 1 minus e power x is L of 1 minus L of e power x. And we know that L of 1 is 1 by x. 1 by s minus L of e power x is 1 by s minus 1. Now we want to find L of 1 minus e power x by x. So in that case, we have to take integral s to infinity 1 by s minus 1 by s minus 1 ds. So that is, what is integral 1 by s? It is log s minus integral 1 by s minus 1 is log s minus 1 from s to infinity. Now we have a formula. Log a minus log b is log a by b. So this can be written as log s by s minus 1 from s to infinity. So that is minus log 1 by 1 minus 1 by s. If you apply upper limit minus lower limit. So that is, if you have minus before log, you can take the reciprocal. That will become s minus 1 by s. This is the final answer. Now next, let us move on to the next topic, that is unit step functions. So sometimes it may happen that we come across functions whose inverse Laplace transform cannot be determined by the formulas which I gave you in the list. So to deal with such functions, we have to define this unit step function, which is also called as Heaviside's unit function. So what is the definition for this unit step function? The unit step function, which function is called as unit step function? U into x minus a. This is defined as u into x minus a is equal to 0 for x is less than a, and it is 1 for x is greater than or equal to a, where a is greater than 0. We can draw this figure to understand it more clearly. This is 0 and this is 1. We are taking u into x minus a, and this is a. This is x. Now, how do you get transform of this unit function? So the transform of unit function is obtained as follows. So Laplace transform of u of x minus a is equal to integral 0 to infinity e power minus sx u of x minus a dx. That is equal to integral 0 to a e power minus x sx into 0 dx plus integral a to infinity e power minus sx into 1. So if you simplify this, you will get e power minus sx by minus x. First term anyhow it will become 0, and we are doing it for the second term, a to infinity. If you apply upper limit minus lower limit, you will get e power minus as by s. Therefore, f of x into u of x minus a is equal to 0 for x is less than a, and it is f of x for x is greater than or equal to a. So the function f of x minus a, u of x minus a represents the graph of f of x shifted through a distance a to the right. Now there is a property based on this which is called as second shifting property. What is second shifting property? Let us see now. If L of f of x is equal to f bar of s, then L of f of x minus a, u of x minus a is equal to e power minus as f bar of s. This is second shifting property. Now let us take convolution theorem. What is convolution theorem? If L inverse of f bar of s is equal to f of x, and L inverse of G bar of S is equal to G of X, then L inverse of F bar of S, G bar of S is equal to integral 0 to X F of U G of X minus U du. Then next, what is periodic function theorem? There are two important theorems, that is, one is convolution theorem, other is periodic function theorem. So if f of x is a periodic function, with period t, that is f of x plus t is equal to f of x, then L of f of x is equal to integral 0 to t e power minus sx f of x dx by 1 minus e power minus st. This is periodic function theorem.